So good afternoon and welcome to the last thing in this week of Advances in Science and Application of Solar Interferometry in the FRINGE 2021 workshop. So in this session, we will have 10-minute presentations of the summaries and recommendations prepared during the week by the session chairman. And now I think I hand over to okay. Right. It looks like that we are missing the summary presentation still from the advances in INSAR theory and methodological applications. So we'll leave that to the end of this session, and I hope that we have the presentation by the end. So we go to the second session then, which is data products and services. I'd like to invite Maria Constantini to present the summary.
Good afternoon. So in this session, there were first one presentation about Luis Besi from Skywatch, and he provided some updates about the developments of Snap Toolbox. After this, there were 4 presentations about different projects on developments and provision of analysis-ready data. In addition to the amplitude images, this presentation also presented interferometric analysis-ready data, because the idea, according to this presentation, is to provide higher level analysis ready data. So examples have been shown, like coherence map, interferograms, even displacement maps obtained on pre-processed data cubes. Next slide, please. Different approaches, different variations were shown. Some of them are working on single bars, other on full frames, and as I said, some arriving to higher level products like interferograms, and promising also unwrapped products and time series. During the technical session, we presented among the recommendation, well, not really recommendation, but at least the recommendation of considering, of evaluating the possible, the provision of higher level interferometric analysis ready data layers. And also another request was about accessing single bus of Sentinel-1. During the technical session, there was a discussion with different opinions on how far these higher level products are of interest and how much they simplify user activity, how much they can be accurate and reliable, because there is the risk of providing higher level products are more difficult. There can be big errors, like for example when we talk about phase unwrapping. And so there were during the discussion different opinions about if providing higher level product was a good idea or not. I think this concludes my presentation. Thank you.
Thank you, Mario. Next one is Francesco De Zan to present the summaries and recommendations from Matrosphere and Ionosphere. So is Francesco in here? Okay, but who is the second chair of this? All right, so this one is also missing. I'd say that we skip to the end and I'll read them in the end. Okay, so then we jump to ice and snow. And here I believe Thomas Nagler is present and I will give the summary.
Yes, next slide, please. We had overall 10 oral presentations organized in 2 sessions, and additional 1 poster presentation with 13 posters. And I quickly summarize the outcome and the observable variables using science interferometry. So related to ice velocity, we had 10 contributions. So the highlights were that we are now in the development, at the end of the development, to provide Sentinel-1 TOPS interferometric products from the ice velocity, and the green light white ice velocity map from INSAR, Sentinel-1 INSAR has been presented. There were also a synergistic use of offset tracking and SAR interferometric phase information from various SAR sensors, including previous ESA sensors and also L-band sensors. And RadarSat for the Antarctic ice sheet-wide velocity map was generated. We had a single and multi-sensor ice velocity maps from SAR in combination with optical sensors for mountain glaciers presented, and already preparations for ice velocity sheet monitoring using current but also upcoming L-band SAR sensors have been shown. Regarding the grounding lines, we had 3 presentations. There was a new approach for delineating the grounding lines by applying deep learning techniques on INSAR data. And there was also an automatic procedure presented for generating time series of grounding lines in Antarctica using INSAR from using different SAR sensors from TerraCX, but also, of course, Sentinel data have been shown. There was one presentation on automatic delineation and detection of ice shelf crack propagation and calving, where an automatic delineation based on the phase gradients in Sentinel-1 time series of INSAR data has been shown. Next slide, please. Regarding surface elevation change and mass balance, 3 presentations have shown the potential of SAR interferometry, where we are looking here for a global inventory of the glacier surface elevation changes from tandem X versus SLTM, applying the TEM differencing, and this was converted to the mass balance to see the ice loss. And also an approach was to detect surface elevation changes using models from time series of ice velocity data. Regarding the permafrost domain, we had 4 very interesting presentations dealing with the time series of the thaw subsidence and frost heave, which were covered with modeling. So this is also an application of time series of SAR interferometry. And also the INSAR mapping of key indicators related of the ECV permafrost in the Arctic domain. And we were looking, had a presentation which were looking on the permafrost degradation in mountain areas in the Himalaya with INSAR. Regarding snow water equivalent, 2 presentations were dealing with the application of the retrieval of snow water equivalent using multi-frequency SAR and pull INSAR. Next slide, please. Within the technical discussion, we had overall 4 seed questions, which were discussed in, I think, a 45 minutes slot. So the first question was dealing with the main gaps in the observation of key ice sheets, glaciers, and snow parameters, and how these gaps can be closed by optimizing the acquisition strategy of current missions. From the monitoring point of view, there was one gap identified. This was dedicated to fast processes, which cannot currently monitored by INSAR because of the repeat pass interval, which is provided by the current sensors. So these would be parameters like tidal forcing of grounding lights, calving, cracking, but also the velocity of fast-moving outlet glaciers, which would require short repeat pass sensors. Currently, only Cosmos Climate can offer one-day repeat pass data, but as far as I'm aware of, there is no systematic acquisition over the ice sheets and ice caps observed. So what is needed is actually one-day or even sub-daily repeat observations. Then we discussed the extent of Sentinel-1 systematic acquisitions for the land cryosphere. Some of the gaps have been identified. So the primary gaps are that we recommend to have a continuous full coverage of the Antarctic margins, so the coast around the coastlines with 6 days repeat, and this would support a couple of different ice sheet parameters. And also on a combined basis, at least in selected regions along the coastline during the polar winter crossing orbits would be very helpful. Regarding the Arctic observations, we recommend to have a full coverage of Greenland and the other Arctic ice caps like Canadian ice caps, but also Russian ice caps, Svalbard, using crossing orbits during the 6 to 8 weeks winter campaigns for INSAR velocity. For Greenland, there was a significant progress already made in the last winter campaign, and only a few spots are missing, but also the other Arctic ice caps should be taken into account. A similar request was made for selected permafrost areas in Siberia, for example, outside of Europe, which should be monitored. We also recommend that studies should be initiated to enhance the synergistic use of different techniques of the tracking, especially with INSAR techniques for large-scale monitoring, which has been demonstrated, but further development is definitely needed. Then, regarding other sensors, there is a coordination of the systematic acquisition of the current L-band SAR sensors like SARCOM and BIOSAR needed for ice sheets and glaciers and permafrost regions, but also mountain areas where seasonal snow is present is of interest. And there are already some of these data sets have been acquired, and access to the archives would be very useful. And then to also snow water equivalent with high resolution is still a pending parameter where a lot of investigations are going on. And here studies using the INSAR approach should be initiated, especially to investigate the temporal decorrelation due to different snow conditions, so melting, non-melting snow accumulation, focusing on the Copernicus SAR frequencies, so C-band and L-band. And also some R&D studies could be initiated on this. Next slide, please. So the second seed questions was on the advancements which can be expected from future approved missions, and which open questions can be called for new mission concepts and techniques. So one contribution was that there is a gap in the systematic observation of high-resolution surface elevation changes of outlet glaciers, of ice sheets and mountain glaciers, where altimetry is not suitable because of the resolution. And currently this is done by Tandem X, but of course Tandem X is not living forever, and the continuation of this mission is currently not planned. And therefore, of course, it is recommended to initiate also R&D studies to go on with these techniques to look for the feasibility of C-band single pass interferometry to fill this gap. And this is also addressed in the next seed question, dedicated for the operation of Sentinel-1 constellation. There is also the need for observing the 3D ice velocity with specific Sentinel-1 acquisition campaigns that can be expected from Earth Explorer 10 candidate mission Harmony. And here one question is that the bistatic backscattering, which is what we will have from this mission for the different surfaces, is still needed. And this should be a preparation study for this Earth Explorer 10 candidate mission. And we discussed also the constellation of Sentinel-1 ABC, but that's on the next slide. Please, next slide. So we discussed here what is the preferred Sentinel-1 orbit configuration. In the case, 3 satellites A, B, C, and C are in orbit for optimizing the observations of essential snow, glacier, and ice sheet parameters. So we discussed 3 options. So the first is the maximization of the coverage when we have 4 days repeat between A, B, and C. Then one would be a single path configuration where A and C or B and C would be very close together, so maybe a few minutes apart. And this would be then a 066 repeat interval. And then a kind of ERS tandem scenario where we have a 1-day repeat pass between A and C, and 5 and 6 for other repeat pass scenarios. We were aware during this discussion that currently only 2 satellites of Sentinel-1 will be operation, but we still discuss this unique opportunity to have 3, in the case budget will be found, to have 3 satellites in orbit. And there was a clear message from the community to have to operate Sentinel-1 ABC in a constellation of 156. So to have every 12 days kind of 1-day repeat interferogram possible, and 5 and 6 days would be very similar. And especially this 1-day pair would have a significant improvement on the coherence. And this would allow to monitor fast changing processes. There are a couple of different processes what we want to see, for example, faster moving glaciers, but also calving events, and then also tidal impact on the grounding line and so on. And these processes cannot be observed with the current constellation of 6 or 12 days repeat. And we think from the ice community that this type of constellation can be a kind of game changer and a big step forward in monitoring various aspects of the land cryosphere. It is also recommended to evaluate the second options where we have a close formation of A and C to investigate the single pass interferometric capabilities at C-band. And this can be done, for example, for several months during the commissioning phase of Sentinel-1C. And this, I think, would provide really a big, important knowledge and contribution to the preparation of Sentinel-1 next generation or also other future SAR missions. But also, of course, this 444 repeat pass constellation is of interest because it improves, of course, the temporal sampling, and but it will have only more or less no or only a very minor impact on coherence and the retrieval of parameters and also the quality of products. So in principle, this would be of the lower priority. Next slide, please. In the last seed questions, we were dealing how Sentinel-1 and L-band SAR missions can operate together. So like SARCOM, NISAR, or the upcoming Rosel. And how to enhance or complement the observations dedicated for ice, snow, and permafrost parameters in polar and mountainous regions. So first on the constellation of Sentinel-1 and Rosel. So from the ice community, almost simultaneous acquisition of Sentinel-1 and Rosel is preferred. So if having the same orbital plane for both of the sensors and the time difference of a few minutes would be acceptable. This would have more or less a dual frequency CL band data set available, which is simultaneously acquired. And this would improve the retrieval of ice and snow parameters. And of course, we can use both data sets synergistically, not only to improve the products, but this would have also an impact on the services. And some examples have been shown. And we propose here also to initiate R&D studies to further develop concepts and algorithms for exploiting the synergistic use of Sentinel-1 and Rosel. Then SALCOM A and B with 8 days and repeat, and ALOS 2 with 14 days repeat pass. They have very similar repeat pass intervals as Rosel with 6 and 12 days. And this would be quite interesting to analyze time series of this data in polar and mountain regions to look for coherence and during changing conditions, and also to prepare INSA applications for Rosel and later on or earlier in few years for NISAR. Another interesting thing would be to look for this the potential of the opposite imaging geometry of Sentinel-1, which is right-looking, and NISAR, which is left-looking, and apply this and investigate and study these data sets for various land cryosphere applications, and also R&D studies could be initiated on this. Thank you.
Okay, I will present the summary of the land cover and vegetation part. Next slide, please. So this session was chaired by Javier Duro and myself, Urs Wegmüller. We had 5 presentations and about 20 posters, of which 10 were uploaded. Next one, please. So the coherence and also other phase-related parameters such as the closure phase relate to land parameters, besides depending also on SAR parameters as to wavelengths, baseline, time interval, noise equivalent, sigma 0, and others. The coherence can contribute to classification type, so land use mapping, crop type mapping, forest mapping, and parameter retrieval type, so biomass estimation, crop phenology applications. Thanks to Sentinel C-band 6 and 12-day coherence is available globally and easily accessible. Coherence and backscatter are complementary and should therefore be used in a combined manner, not just one of the two. There is an interest in using multiple polarizations and wavelengths in the community. This also improves the performance of the retrievals. Multi-temporal datasets are particularly useful for land use and vegetation applications, and this is definitely one important contribution obtained so far from Sentinel, these nice time series available over many parts of the Earth. Thanks to the systematic data acquisition with 6-day intervals and short spatial baselines, Sentinel-1 has a high potential for land cover and vegetation applications. The 6-day coherence performs clearly better than 12-day coherence is another finding. And many of the algorithms used, for example, using machine learning, depend on access to training data. The algorithms work well for the area of the training data, but the method cannot reliably be applied elsewhere. So that's a little bit of limitation of some of the work that was presented. Next slide, please. I will now summarize some feedbacks to ESA, first concerning sensors and missions. The land cover and vegetation scientists and users are not really a well-established close community as, for example, the glaciologist scientists. So it's not so easy to speak with one voice or to make a very strong point to ESA. Nevertheless, there are many, I think, in these communities and many interested parties. For Sentinel 1A, 1B, systematical acquisitions with 6-day intervals as much as possible and 12-day intervals elsewhere are requested. Dual pole data is preferred over single copolarization data. So overall, you are doing a good job so far, I would say. Changing modes, for example, the polarization should be avoided as much as possible. And also here, I see it's done really well with ESA. By ESA, we have reliable data or consistent data most of the time, almost everywhere. For Sentinel 1A, 1B, 1C, we discussed the operation in different modes. So the operation with 1, 5, 6-day intervals and the operation with regular 4-day intervals are both attractive for the land cover and vegetation applications. The short 1-day interval can contribute additional, somewhat complementary information, while the main multi-temporal rhythm remains at 6 days. The regular 4-day intervals, on the other hand, would improve the temporal sampling by reducing the intervals to 4 days. There is a high interest in having Sentinel-1-like data also at other frequencies, such as L-band or S-band. Next slide, please. So here we give some feedback to ESA concerning research and development ideas or suggestions. At present, most algorithms depend on training data and can therefore not easily be scaled. Developing physical models, scatter models, coherence models based on algorithms would be useful. ESA could support this through some study contracts, for example. The advantages, disadvantages of different S1 ABC schedules could be investigated also. 1-day C-band data is available from the ERS tandem mission. 3-day intervals are available from the early phases of ERS. So quite some investigation could be done to maybe have a better idea which of the two modes would be preferred for land cover and vegetation application, but this could, of course, also be done for other applications. One of the posters showed that Sentinel-1 coherence data is or can be available at global scale. What can be done with such global coherence data? This could also be something which could be used in the ESA CCI projects, or it could be investigated in some new studies maybe initiated by ESA. And what is the benefit of additional frequencies? Preparations for the times when L-band coherence will also become widely available could be addressed again in scientific studies or also in ESA studies, of course, if there's the possibility. This concludes this part. Thank you.
Thank you, Urs. Next one is volcanoes, and Susanna Ebmeyer, you can have the floor.
Thank you, Marcus. I'm presenting the results from the Volcano section, which was co-chaired by myself and Virginie Pinel. We had 5 oral presentations and 23 posters on Wednesday of this week and spanned a broad range of topics in volcanology. A significant number were related to volcano monitoring of unrest and eruption. And there were also research results with a few emerging themes from the group being mechanisms for caldera unrest, integration of INSAR and SAR measurements with other remote sensing and ground-based data sets, automated processing and automated signal detection. And there are also a couple of talks and posters related to tracking the progression of eruptions using diverse SAR methods beyond INSAR. I'm going to move from that very brief summary to cover the main themes that were dealt with during our discussion. I should say that we had our discussion late on Wednesday afternoon, and we wrote a couple of emails out to the Volcano INSAR community to try and broaden the group from whom we were getting feedback. And we had a few responses from people there who are active in Volcano INSAR, but didn't find this an easy time zone to engage with. So that the discussion points here are a compilation from things that were said during the technical session at Fringe, and also in responses to the emails. So similar to the ICE community, we as a group certainly would support arguments for Sentinel-1C being active, unsurprisingly. In terms of the configuration, I think there are advantages from a volcanological point of view of having a very regular acquisition strategy, so every 4 days. But there are also specific cases where a 1-day repeat can be very useful, and we know about those from particular phenomena that have been observed with Cosmos SkyMed 1-day repeat that haven't been observable with other data sets. So for us, there are advantages in both directions, but I think there's more of a case for a 1-day repeat than from other communities. But what we would like to add to the comments from the ice and snow group is that we would particularly like to be able to request Sentinel-1C coming on during periods of volcanic crises, episodes of unrest, or eruptions that are considered particularly dangerous. Although it's not something that's formally in place in the same way as the polar community has at the moment, we aspire to have an international community-led coordination for SAR tasking over volcanoes in unrest and eruption to avoid conflicts in tasking of SAR instruments, and also to make sure that the most useful imagery required both for research and for hazard response. One point that was raised during the technical discussion, which I think was particularly broadly agreed with from lots of different groups, was the necessity for up-to-date digital elevation models in volcanological processing particularly. And that's something that's of relevance to the proposed Harmony mission. It's something that matters in particular for high-quality automated processing of Sentinel-1. And the other point related to automated processing is that for volcanology, we would like this to take place at a higher spatial resolution for volcanoes where that's possible, because there are certain types of signal that get missed with higher degrees of multi-looking. Another point that came up during the technical discussion was the role that perhaps commercial SAR imagery has in response to volcanic eruptions. One example of this was the Nyiragongo eruption, which happened last month. Within 24 hours of the eruption starting, there were 2 commercial images acquired, which provided the first information about changes at the Nyiragongo summit crater, and also lava flows flowing into the city of Goma itself. So we think that this kind of commercial imagery definitely has a role on these short timescales, and we welcome that, for example, ISI is now acquirable through an ESA third-party emission scheme. I think that was just announced this week, and that's really good news. But in general, acquiring commercial imagery is challenging. We think the charter alone is perhaps not quite enough for our needs, and that it's an area in which there are different routes that would be perhaps fruitful to explore. Our final feedback point came particularly from colleagues in Chile, and I think it's something that might be echoed from people working at volcanoes in different parts of the world, is that we would like Sentinel-1A and 1B acquisitions to continue to retain the shortest possible achievable repeat time over volcanoes that are particularly active. And there's a specific example included here, an area of southern Chile where there are descending tracks that take place at 12 days and acquisitions on descending tracks that have happened at 12 days, where 6 days would be very helpful, and only intermittent ascending acquisitions since 2019. So that's a very specific point which we can kind of feed back as a community. I'll leave that there. Thank you.
Thank you, Susanna. Next one is earthquakes and tectonics, and Masato Furuya, please.
Yeah, hello. So I'm presenting a quite large group of
Henriette, please.
Yes, I'm representing for many colleagues who shared these sessions, and also, of course, for the wider community. Next slide, please. We had many presentations, many very nice posters, and we had also 4 sessions with oral presentations. And I will not do any of these justice by trying to raise some particular points. I think what we have seen in general is that we have now large area coverage with displacement maps, such that we can see large tectonics faults loading, moving, creeping. We can see now that faults are folding. So this is something that I find very, very spectacular, actually. And so this is Sentinel is pushing that, and this is super nice to see. So please have a look at the YouTube posters as well after the events, and replay the talks if you like. For earthquakes, it's also we have also earthquakes, and there was a comment from Cécile Lasserre, who said, well, remember when we were back in FRINGE, other FRINGE meetings, we had sessions where we would see different studies on the same earthquake. I think these times are now over because everyone basically has its own earthquake to study, and we should keep up. So thanks, ESA, because the open data policy has really brought this along, and we have great coverage over the tectonic areas, and this is fantastic, and I think we will see a lot in the future. We have mass producing services like Lixa, like ARIA, who bring also displacement maps to the people, so process displacement maps, which is very nice, and is also received very well, and many people are using this. So this is really nice. Maybe a small note that is not on the slide here is what we also see is advances in modeling these processes, so that we basically build new modeling tools. But we feel that this could be more, and our feeling is that everyone is still looking at the nice data, maybe, and that we do the method progress maybe a bit later. Okay, next slide, please. So we have recommendations as well. And one is that we just have seen a few studies that bridge between ERS and Sentinel-1. And we are not so sure how, we think it's not easy enough to just grab NVSAT and ERS whole archives for time series analysis. So I think we think this is this needs to be looked at, such that we can really combine this, and we have a really nice long time series. There was an example like the ALOS data that is accessible through the ASF facilities. So this was an example to say, well, this is nicely done. We also comment on the Sentinel-1C that is coming up, maybe in the time when Sentinel-1A is still alive and feeling good. And we could second the recommendations of the previous groups. So we think that 666 days would 444 days would be great, also for earthquakes, but we would also support like this one-day repeat cycle, because we think we can also, like the others, maybe see signals that we haven't seen before. And similarly to the Volcano group, we would also think that at least, if budget allows, have it as an emergency response. This is also very important for earthquake analysis, that you then have another sensor who can jump in, maybe as a plan B. We have a lot of algorithms developed for long-term time series analysis and large space, and we see many nice examples. But we think what is missing is maybe something that we really know that we would arrive at the same result if we would do the same study over the same area. And so we would need some benchmarking and some quality checking, maybe. The thing is that this is considered a very exciting work, and to look at the very nice data is always the better option. But we think that this is important, such that our product, these time series, that we as a community ensure that the quality is high in general. So this is also an interest of ESA, and maybe there could be some incentive, some funding schemes or something like that. Maybe you could look into this. We would appreciate this, yeah, if there would come support from ESA. Next slide, please. We see that for that there's some initiatives that we can have absolute ranging from SAR sensors. We know that INSAR measurements are always relative, and we think that maybe we can overcome this when we have now so great orbit information. If ESA could provide or could help us and stimulate going into that direction by providing more corrections, particularly from the atmosphere. We have methods also for the ionosphere, but they are not really implemented. They have been around also in at the last FRINGE meeting. Something like extra layers that one could add to the data, and solid earth tides, something like this. So just that we are going into this direction, that we can have absolute measurements, we would find this very useful. The next recommendation is about the north-south component. We see more applications, maybe something from the summary, where we use the burst overlaps of the TOPS mode that we found so awkward in the beginning, because we have these overlapping areas and some steps in our interferograms. They are used more and more, and actually we appreciate that. And now we are a bit worried that when we not use the TOPS mode in future next generation satellites, that we lose this signal. And now we talked about harmony, how this is taking care of that, but this is not a operational long-term mission, and we would like to ask ESA to look into that, such that we can keep the sensitivity on the north-south component, which is one of 3 components. So quite a large part, actually. Okay, and the next recommendation concerns maybe the usability of the data when we study an earthquake. It could be a small earthquake. It's just covering like 3 bursts of an entire frame that one can download, so 7 gigabytes. We would like to ask ESA to have a capability to download single bursts. But that's somehow possible, because it would save a lot of user disk space and energy. Yeah, because we may have this in some cloud service. It's always on, and you know what I mean. And the next thing is, and I think this came also in other technical sessions, that when we do INSAR, everyone has to co-register the images, and so this could be a step which is maybe already done before we download even the SLCs. So this would be very nice, or maybe just as metadata, that you can just apply the correction without doing a co-registration. I think this kind of, no, this was, we don't need this anymore. This was the seed questions from the technical sessions. Maybe just a kind of personal note, but I think I'm speaking for a lot of my colleagues. I bow my hat to the nice gender equality of the Volcano group, and I think our other groups, they can. We need to work on that. I was checking a statistic once. I did it now again. In my community, we have 50%, more than 50% female students. We have 50% female PhDs. And then somehow it separates the statistics. That's all from my side. Thank you very much. It was a very nice meeting.
Thank you, Henriette. Okay, so next one is subsidence and deformation, and who is here to present?
Tazio.
Okay, so Tazio Strozzi, you're welcome.
Okay, so we had this 4 oral sessions on subsidence and deformation. 3 yesterday and 1 this morning until 11 o'clock. So we didn't have much time to prepare the summary and recommendations. And I would like to thank in particular Maya Leva for the support of that. And I apologize if there are mistakes or something is not well explained in PowerPoint. So for the summary, we didn't have the time to prepare a real comprehensive So I'm just watching the PowerPoint. Is that correct one? Yes, I think. Sorry. As I said, we didn't have the time to really prepare a comprehensive overview because also there are range phenomena or a wide range of phenomena which were presented. And so we have here more a list of points describing the 4 sessions. And the first one, wide area processing, was presented. Europe, Norway, Iran, and active reflectors. Challenges, progressive on that reflectors were. The second session, it was a diverse session with presentations again on electronic phonoreflectors, machine learning for post-analysis of large data sets, concept for integrated INSAR with other geodetic data sources, water management and groundwater effects. The third session, again, was rather scientific, or more scientific than technical. 4 presentations were on sinkhole monitoring and 1 about landslides. And for the sinkholes in particular, there were presentation or approaches at the systematic and automatic system to see precursors of. Next slide. The 4th session this morning had different talks. One on, again, on deep learning, this case for unwrapping procedure of data. One on increased efficiency of INSAR processing, focusing small patches. The third one was an integrated monitoring of rock glacier landslides using sensor, multi-platform, phase, and amplitude. One was a nationwide processing detecting a wide variety phenomena. Piecewise temporal processing to optimize detection and time series deformation was another presentation. And the last one in the session was about the uncertainty assessment of decomposition ascending data. And I want also to all that we had, I think 77 posted contributions. I copy and paste in Excel. Hope the number is correct. We didn't have really the possibility to browse all these contributions, but we think as chairman that they were presenting very interesting scientific results and not many problems or recommendations were reported so that we can pass back to. Next slide. We had this morning a Q&A session. There were 4 questions that were raised by the chairman. The first one was about these wide area ground motion services, and the question was about the evolution of that service. People were saying that there could be a natural evolution towards emissions like L-band for vegetated areas, very high resolution, that is Cosmo, more loops to get the 3 components. And there was a maybe standardize the data from the initiatives. And here we didn't know how to formulate a recommendation because the Copernicus European Service is Copernicus, the national but maybe ESA can say the standardization of products, create something to stimulate standard wide area product. There was also one remark at the end of the session about ground infrastructure, so phonoreflector, compact active responders. They can enhance the products from Sentinel. And the question here again is not a recommendation, it's a question. We need to investigate if there is a mechanism that the satellite operators can acknowledge these infrastructures on the ground, so to promote those, so promote the way of having more of this infrastructure. The next slide. We were discussing also this short-term kilograms, the problem of multi-looking phase closure signals that appear. And the question, what question was, what is the correct approach to treat this effect? And I think here one clear message from that the short-term kilograms, they should be retained, because it is very important information we recover for them. First, a proper processing approach, also including proper filtering, is needed for that. But nevertheless, there are these physical phenomena which we don't understand. So the recommendation is target studies for an enhanced understanding of this physical scheduling properties, mechanisms, but also for a proper processing of the recommendation community. Next slide. The third question was in general about deep learning opportunities. And here the message for the recommendation is to stimulate such initiative, for instance, for the information patterns identification, handling large data sets. I think that ESA is also working that line. Then the third question was more general about Sentinel relation or the other is general. So what could be of benefit for the community in terms of having an other relevant properties or other way to analyze the data. And I think the clear requirement for the community is to go on with the Sentinel-1 constellation now, so compatible data long time, because any opportunity to change the mission strategy will fragment the data. But of course, that can be considered for other complementary missions. Thank you.
Okay, thank you, Tazio. Next one is INSA for the built environment. Who's here to present?
I'm here, Marcus. This is Francesca.
Francesca, please go ahead.
Yes, this summary is on behalf of the four of us as chairs of the session. We been particularly enthusiastic about the outcomes of this session. The size was smaller than other thematic sessions, but actually we were amazed by the number of contributions and the quality of the contributions. We've had in particular 10 oral talks yesterday and 45 virtual posters on Wednesday. It's a huge number considering how small and specialized is this community. So when we talk about built environment, we are looking at any kind of built infrastructure, human built infrastructure. And the typologies of infrastructures that were covered were an extremely wide range. We've been trying to map all the typologies that were covered, and they span from the typical built-up areas like entire cities up to single building scale, but also infrastructure dealing with transport like roads, highways, bridges, metro lines, airports, railways as well, and utilities and any kind of oil and gas infrastructure as well, and dams as tailing dams and embankment dams were last but not least in the session. So in the next slide, if you can please change it. Oh, this is the wrong PowerPoint, but I'll speak through that. Don't worry. We've tried to convey the main messages from our session. I'll try to give you the key conclusions based on the seed questions that we worked on during the technical discussion today. The first one was about the need for high spatial and temporal resolution. This is a key requirement for the community. because as you know, when looking at infrastructure monitoring and the scale of this typology of target, what we need is to have both high resolution in time and space. So this was a key requirement that will be well accommodated by some of the technical decisions that have been discussed during the FRINGE over the week. So if you go to next one, please. So next technical discussion point was around using INSAR in different components and phases of the infrastructure life cycle. We've got an extremely good representation of applications in all different phases of the infrastructure cycle. So we cover design, planning, construction, monitoring, and maintenance. What we found that probably there's some technical gap that we can consider as a community in the future to push a bit on teaching about INSAR data and INSAR theory in civil engineering courses to make sure that we pass on technical and scientific background skills to new civil engineers and geotechnical engineers that will be able to use these techniques in a more mature way, let me say, in the future. So can you go one more? Okay, this was one of the hot topics we think of the technical discussion, because we've been trying to focus on the capability of INSAR methods to provide information suitable for early warning and alerting. This is, as I said, a hot topic in the literature. It was also somehow represented in the session. So we as a community were quite worried because a lot of attention must be paid and must be made by us as a scientific community when communicating INSAR results outside and to infrastructure managers and specialists in the sector. And this is particularly relating with prediction, early warning, and forecasting concepts. So before we treat and communicate an anomaly that we see in the time series as a potential button to push to give an early warning, we should be very careful and to support this with robust statistics and statistical analysis. If you can go one more. This topic is about communicating results, which links to the previous topic in uncertainty. It's of particular importance in our community because we are dealing with civil engineers, topographers, surveyors. So every time we communicate results, it's let me say, it's a must to be very, very specific on the precision of the data, the accuracy, the geolocation, and also the detection capability of INSAR to make sure that we deliver the right message as a community. We've been dealing with approaches to communicate the results to the different specialist infrastructure community during the talks and the posters, and some examples were about the approaches to convert the data into information useful for structural health monitoring applications. Can you go one more? So this is, okay, yeah, thank you. This is just to back up what was said during the technical sessions, because we as a community fully support the idea of the enhanced continuity that the next generation of Sentinel-1 will be providing to Sentinel-1 current constellation, because on one hand, we would like to keep the current capability of the constellations in terms of interferometric applications, not to lose the link with the previous and current constellation. And on one hand, we would like to fully exploit the new possibilities, for instance, the enhanced swath width and revisit cycle and any opportunities that we will have to enhance the spatial resolution as well. Some suggestions here that we put together before the technical discussion was about the possibility to be involved as a community in the analysis of the different scenarios that could be considered in this regard for new initiatives and new satellites, new opportunities for the community. But basically, all the technical points that were raised also during the oral session and the Q&A were perfectly in line with the other thematic sessions and also with the advanced INSAR method sessions and the data and product sessions. So we're fully aligned with those. Last one. Thank you. So this was a very specific question that was raised by one of the speakers. So it's more like a technical request to make sure that ESA considers the possibility to process either regularly or on demand extra wide swath data for the Arctic regions to make sure that not only ground range detected and raw data are available, but also single look complex because they could be vital for the infrastructure community. Thank you.
Thank you, Francesca. Okay, and now we go for a couple late coming presentations. So next one is atmosphere and ionosphere, and Francesco De San, please.
Yeah, hi. I'm not sure which deck of slide is this. Yeah, okay, it's the new one. Thanks. So this is to summarize the atmosphere session. We had 5 talks. So on the ionosphere, I would say there's an agreement. GNSS models are very useful, especially at C-band. But we should not forget the top part of the ionosphere above the satellite. And for this, JPL was presenting some idea using the GNSS on board to estimate the top part of the ionosphere. This correction is relevant for longer wavelengths, of course, and more. Everything is more challenging for L-band, so normally we do also split spectrum. Without rely on GNSS leaves residuals in the meter range, in the meter range. In azimuth, it will be worse. And JPL was also presenting their difficulties applying split spectrum with a quasi-quadpole mode, which is discussed for NISR. Regarding the troposphere, I would say that we see now global weather models as a well-established technique to correct SAR, both for geolocation and for the phase. From Japan, we had an interesting presentation about possible dispersive effects observed at L-band with heavy rain, and the physical nature should be clarified looking at higher frequencies like C and X-band, where the effect should be larger. And then we had also a presentation about improving offset estimation in the zenith wet delay for ingestion into weather models. Considering all corrections together, so the ionosphere, the troposphere, solid earth tides, and instruments, and everything, we reach now decimeter level, or even better for Sentinel-1 for absolute geolocation. So this was a summary. So the next slide is about recommendations. The first recommendation is especially directed to NISR. It was don't adopt quasi-quadpole if you want to apply split spectrum for the ionosphere mitigation. In case if this mode is adopted anyway for other reasons, of course, then the recommendation is to apply the split spectrum to the main bandwidth, be it 20 or 40 megahertz. The extended time annotation dataset would help, so making this dataset available would help both the geolocation and interferometry for Sentinel-1. And this leads naturally to something which was also mentioned before. So consider generation of blindly co-registered products for C-band Sentinel-1. So now this is clearly possible. And then I've added that if we want to have like similar comparable performance with L-band, like maybe for Rosel, we should investigate solutions for absolute geolocation and also for the phase because of the stronger impact of the ionosphere. So the same performance is not to be expected from applying GNSS corrections to L-band data. So this is the end for my session.
Thank you, Francesco. Next one should be advances in InSAR theory and methodological innovations. And Ramon Hansen is presenting. And Ramon, you need to share your presentation yourself.
Okay, let me see if I have the opportunity to do that. I think I need the rights to do that. So Ryan, is that you? Can give me? I got it. Yeah, great. I need to find. Does it react here?
Ryan is saying hit the share button.
Yeah, I'm doing that. Nothing's happening. Maybe I can just do it orally, and if I'm finding the way that it will work, then it's okay. But I won't keep you up. So we had 3 sessions on advances on InSAR theory and methodological advances. And in those 3 sessions, we had 15 talks with 32 e-posters.
Excuse me, Ramon, could you try again? It might work now.
Okay. Yeah, it's not reacting to my share button. The share button is live, but I don't get an. I sent the presentation, by the way, so it's in your email, so you could also open it.
Okay, so Octa will share.
Yeah. Okay, then I'll just continue, and if you can open it, then that's fine. So I'll report on the main aspects of the presentation. So there was one presentation on wide swath SAR and proposing the use of the PRF dithering for as another processing approach with several advantages. And there were 3 presentations on what is either known as the fading signals or the closure phase or systematic biases and the properties there, both from the perspective of seeing that as a nuisance signal, but also by extracting information from that. And that was a topic which was also discussed later in the week with different opposing views, which makes the conference like this very interesting, I think. We had 2 presentations on machine learning and data fusion. So this shows that on that level also quite some development. And I must say,
Okay, there seems to be a technical problem with Ramon. Eric, would you happen to have the copy of a presentation, and would you be ready to? Oh, we have it. So okay, Magda, if Eric Fielding, if it is possible, Magda will present the slides and take over.
you still hear me?
Yes, I can see him.
Good, great, yeah. So these all 3 were related to quality aspects. We had 2 presentations, which I would call the 1D, 2D, 3D displacement estimation, and the different perspectives on that. Also very, very useful. And then there were a couple of presentations which dealt with extracting more information from the data themselves. So there was a clear case of more systematically using the amplitude information that we sometimes tend to oversee in NSAR. There was a presentation on using contextual information. So in many cases, we don't only have the SAR data, but we know more about the area that we're looking at, and we can use that also in the processing itself. There was a presentation on fuzzy entropy methods for time series analysis, which came back to the point that the way that we describe the temporal behavior of our points, we tend to use the same parameter for each point, like a velocity or so. But obviously, in many cases, different points have different types of behavior and need their own parameterization. And finally, there was a presentation on the combination of different sensors to extract deformation information. And so this is my basic summary. And if there is one thing, we didn't really get to real recommendations, but I would like to take the opportunity to also underline this proposal that was already made before in this session on investigating the opportunity to co-register the data already on at ESA's premises, and then making the register data available. So what we see is that more and more groups are working with large data sets, and that means that there is a lot of file I/O, both from ESA servers, but also if you have a cluster type of environment, then often you need to move data forth and back. And if the registration step could be overcome, and that is a step that everybody needs to make, that would make life a lot easier and save a lot of disk space, save a lot of unnecessary processing that a lot of people would repeat. And that would leave the opportunity to focus mostly on the value adding on top of those registered stacks. So I would like to leave it with that. Eric is also in the meeting. Is there anything, Eric, that you would like to add to that?
Oh, that's an excellent summary. There were a lot of interesting posters on a wide variety of topics that are hard to summarize in a short time, as we're already over or past the time of this session.
Okay.
Thank you. I hope that you will update the presentation with recommendations, and we can do this via email afterwards. So thank you, Ramon and Eric. So I think it's time to close the workshop. So I have a few slides to show myself. So I will try to share them. Okay. Seems to be. Oh, do I have a problem here? Let's try again. Okay, so now we'll just have to see that. Here, application, okay. I still need to switch the did that already. Okay. Yes. Okay, so just sorry for this small difficulties. All right, so we've reached the end of a very hectic week. I show again this slide that we had more than 100 oral presentations, and then the big number of high-quality posters. So we really had well, it was impossible for us to hit all of the great presentations into oral slots. So yeah, so the numbers are bigger than they ever were. So since it's easier to join online, we had almost 1,300 registered people from 79 countries. So this is a record. Shows that even though online workshop has many downsides, it's one upside is that at least that it makes the workshop globally available. We had more than 1,000 people umbrella. There were 1,500 chat messages almost sent around. And we had 150 or 150 meetings organized between people on the program. It's not as good as it would be in a live workshop, but it's still remarkable. So we've shown that the virtual Fringe is possible. So this of course needs work and participation for many people. So I want to personally thank every one of you, all the participants, scientific committee, chairpersons, organizing committee, and within the organizing committee, I have to single out Sabrina Lodadio, Ulla Väyrynen, and Magdalena Petrucci for their great amount of work that they did for this workshop. But without them, we would have gotten nowhere. And then in addition to that, I'd like to thank Matteo and Veronica from the NICAL team and the NICAL team, as well as all the people of design and data who made the streaming possible and helped us with the technical difficulties. So I close Fringe 2021 here. I can say that the next meeting, I'm pretty certain, will be a live meeting, but also a hybrid one. I think that we need to make a live meeting and then combine it with the possibility of the people worldwide being able to attend virtually. So I'm happy to announce that we are together with Ramon Hansen. Thank you, Ramon. Looking for possibilities to organizing Fringe 2023 finally in Delft. That we tried to do already last year. So thank you very much, and you will receive the summaries and recommendations. We will document them, and we will place all the presentations online so that they will be available after the workshop. So thank you very much.